Hello everyone. Welcome to this series of videos on Thevenin's equivalent circuit and Thevenin's theorem. Okay. So I have been making a few questions. I've been solving few. I think already I solved about 4 questions in my earlier videos in this particular playlist. So now in this particular video, I'm actually, this is the 5th question, but I've just put renumbered, starting with 1. So in fact, I want to make this a slightly longish video where I will be solving a series of problems. Okay, 4 problems I'll be solving. So this is the first problem. So the question is always same: find the Thevenin's equivalent circuit across terminals A and B. So later here the load resistance value is not given. So for example, between A and B, if I connect a 5 ohms resistance, what will be the current in that? So in order to determine that, we need to replace this entire circuit with a single voltage. So this has to be replaced with a single equivalent, Thevenin's resistance in series with a Thevenin's voltage source. Okay, so in all respects, the left side circuit and the right side circuit should behave exactly the same way. So if I connect a 10 ohms resistance here, how much current it will take? If I connect a 10 ohms resistance here, same current it will take. So we need to choose the values of VTH and RTH such a way that this entire circuit is replaced by a simple voltage source in series with. That is the whole concept of Thevenin's equivalent circuit. Anyway, so this problem I'm going to solve. Then one more problem I'm going to solve is this one. This is called second one. In this also, although you may see A, B, C, D, F and all that, still find the Thevenin's equivalent circuit across terminals A and B. The third problem I'm going to solve is this one. Find the Thevenin's equivalent circuit across A and B. Again, the data is same, just the circuit is different. The problem statement is same. Then the fourth problem. I think in fact I have one more problem, the fifth problem. Okay. So using the Thevenin's theorem, calculate the potential across terminals A and B, and here the load resistance value is also given. The RL load resistance 3 ohms is given. Otherwise you can just ignore this and find the Thevenin's equivalent impedance of this circuit, and then you can later on introduce this 3 ohms resistance and you can find the potential difference. Okay, that's a different this thing, but these are the 5 questions. Okay, so you can, if you want to solve this problem, you can pause the video now and try to solve this problem. Similarly, you can pause the video here for the fourth problem. You can pause the video here for the third problem. You can pause the video here for the second problem, and you can pause the video here to solve the first problem. So I have given you the questions. You can pause at any question you want, and you try to work out the solution, and now you can compare that solution with my solution. I strongly suggest you, in fact I request you to try this, before just simply seeing this video as a movie. Even though you are not an electrical engineer or some other specialization, still you try to attempt and try to solve these problems, and then you compare your solution with my solution, so that you can cross check your understanding of this. Okay, so with this I'll try to work out these things. Also, I will keep I think in the YouTube it is possible to specify the timestamps for solution of each question. Okay, so one by one I keep solving it, and I will provide the timestamps for solution of each of these problems. Okay, so with this let's get started with the first problem. Okay, so I am starting here. So solve using Thevenin's theorem. We need to find this thing. So we have only 2 steps, right? So step 1 is find Thevenin's resistance, RTH. Okay, so how do I find Thevenin's resistance? All the voltage sources can be short circuited, and the current sources can be open circuited. Here I don't have any current source, so I short circuit this. So then the circuit becomes something like, so this is short circuited in parallel with 40. So in effect it's actually nothing. So because in parallel with 40, if there is a short circuit, this branch will become completely redundant, so you can ignore that. So we have 20 in series with 20, so that is like 40 in parallel with 10. So 40 in parallel with 10 in series with 16 and 16. Okay, so that is our actual RTH. Okay, so RTH is nothing but 40 in parallel with 10 and in series with 16 plus 16. Okay, so if you're not understanding this step properly, let me just show you. So here it's a short circuit and in parallel with 40, and here we have 20 and another 20, and then we have 10 here, and then 16 here and 16 here. So this will become, so this 40 becomes redundant, so 20 will become series. So I'll have like this 40 10 and then 16 16. So this is nothing but 40 parallel with 10 plus 16 and 16. Okay, so what is this? So 40 parallel with 10 is 40 into 10 400 divided by 40 plus 10 50. So 400 divided by 50, 40 divided by 5 or 8. 8 plus 16 plus 16. So 16 plus 16 is 32. 32 plus 8 is 40. Okay, so this is 40 ohms. So we don't need a calculator. Just by observation we can do that. So Thevenin's impedance or resistance we calculated. Now the next step, step 2, is find VTH, Thevenin's voltage. Okay. So here let me draw the circuit here on the right. So we repeat the same circuit. Now this branch has nothing, so no current here and no current here. So simply the potential at A and potential at C will be equal, potential at B and D will be equal. So now I will simply simplify this circuit and then say this is 10 ohms, and this is for all purposes our AB point, okay, A or C and B or D. Next on the other side, so we have something like this. So 120 volt, and then we have 40 ohms, and then we have 20 here and 20 here, and then this is connected like this. So the objective is to find the potential across these 2 points. Okay, that means we need to find the current in this branch. Okay, what is the current in this branch? So because the potential here and here is already known, 120 volts. So the current in this branch will be V by R. By the way, that is not required in this. So now what is the current in this branch? Okay, so 20 in series with 10 in series with 20. So 20 plus 10 plus 20. So 40 plus 10 is 50. Okay, so here total resistance is 50 in this path, and the voltage here is 120, voltage here is 0. So the current here will be 120 divided by 50 or 12 by 5. So 12 by 5 will be 2.5 amperes. Okay, so 12 by 5 will be 2.5 amperes. Let me just verify that. 12 divided by 5. Yes, I'm not against. Oh, I'm sorry, 2.4. Okay, so good. So I'm not against using calculator, but for if it is as simple as simple addition, you don't use calculator. Anyway, so here it is 2.4 amperes current. 12 by 50 or 120 divided by 50. So now what is the voltage drop in this? So 2.4 into 10 is 24 volts voltage drop. So therefore I can simply say VTH. Okay, so here I will write VTH equal to 24 volts. Okay. So now I have both these values. So I can say VTH is 24 volts and RTH is 40 ohms. Okay, so this is the equivalent Thevenin circuit across terminals A and B like this. Okay, so this is the first problem solved. I hope my answers are matching with your answers. So let's continue to the second problem. Okay, so now comes the second problem. So again, you can pause the video here, try to solve this. Now the question is say find the equivalent resistance across, find the equivalent Thevenin circuit across AB. So let's simply, so this also again we need to replace with the simple source like this. So here VTH and RTH between terminals A and B. So step 1, find RTH. Okay, so Thevenin's resistance. For this we need to short circuit the voltage sources. So this part is short circuited. Okay, so your D is short circuited with F. Then we have a branch here that is 6 and another resistance here, that is 12, another resistance here, that is 4, and this point is our point B, and this point is our point A. Okay. In fact, this point is also our point A because these two are short circuited. So meanwhile, this point is also point C because this is directly connected to C. F is directly connected to C. F and D are short circuited. D and A are short circuited. So A, D, F, C, all of them are actually one and the same. Okay. So meanwhile, this 8 ohm resistance also I need to consider, which is connected between these 2 points. Okay. So this is 8 ohms resistance. Now let us further simplify. So these points, if I make it together, so I get something like this. So this is all that is A, D, F and C. So all 4 points represents the same thing here. Then I have one branch going to 6 and one branch going to 12. So I have one branch going to 6, another branch going to 12. And those two are meeting at one point. So the 6 other end and 12 other end are meeting. From there 4 is going to B. Meanwhile, there is another point, another resistance directly going to B with a value of 8. Okay, so 8 ohms. So this is how we have to resolve this particular circuit. Now again, this one, what is 12 parallel 6? Okay, so 12 parallel 6 is 12 into 6 divided by 12 plus 6. Okay, so 12 into 6 divided by 12 plus 6 is 18. Okay, so 18. So I'm getting 4. Okay, so this resistance is 4. Okay, so I have this point A, and then this resistance is 4, another resistance is 4, and this point is B. Meanwhile, these two are also connected in series with 8 ohms. Now again, this circuit can be further simplified, simply 8 parallel 8. Okay, so 8 parallel 8, therefore RTH is nothing but 8 parallel 8. So that is nothing but 4. Okay, so when two resistances of equal value are parallel, it will be half. So or 8 into 8 by 8 plus 8, so it will become R square by 2R, so it will be R by 2. Anyway, so that is 4 ohms. So here the Thevenin's resistance we have calculated. Now coming to Thevenin's voltage VTH. So how to calculate Thevenin's voltage? We redraw the circuit and reintroduce the voltage source. Okay, so let me do here step 2, VTH. Okay, so determining what is VTH. Okay. Now let's analyze the circuit here itself. You see 4 and 8 are in series as far as this voltage source is concerned. So 4, because I am interested in first finding the currents. Okay, so 4 and 8 are in series, therefore the combined resistance is 12. 12 and 12 are in parallel, so therefore the equivalent resistance will be 6. 6 and 6 are in series, so total resistance will be 12. So 48 volts divided by 12 ohms, 4 amperes of current will be coming out here. Okay, so that just by observation I can find that. Okay, so plus minus 48 volts is the voltage here, and I have 6 ohms here, and then I have 12 ohms here, and then I have 4 and 8 like this. Okay, so this point is A and this point is B. Okay, so but for the time being we'll not worry about this AB. Just see that 4 and 8 are in series, so it will be 12. 12 parallel, so it will be 6 series, so total resistance will be 12. So the 4 amperes of current, because V by R, 48 divided by 12. Okay, so that will be, so 4 amperes. So 4 amperes is flowing like this. Now how much it will divide on both sides? Obviously it will be dividing 2 amperes and 2 amperes because equal resistance is there on both the sides. Okay. Now how to find VAB? So our VTH is nothing but VAB, or VAB is nothing but KVL from B to A. So KVL from B to A. So now I start at this point and go upwards. So 4 ohms into 2 amperes, so 8 volts, and I am increasing my voltage because current is coming down, so I am going higher potential, going against the current. So VAB equal to plus 4 into 2, so that will be increasing voltage. Similarly 4 into 6 I am further increasing. Okay, so plus 4 into 6. So in this case here ohms and amperes. Here also this is 4 is amperes and 6 is ohms. So just don't get confused there. So 4 into 2 is 8 and 4 into 6 is 24. So 24 plus 8 is 32 volts. So the Thevenin's voltage is 32 volts. Okay, so therefore here I get 32 volts as my VTH, and this is your Thevenin's equivalent source across the terminals AB. Okay. So again, I hope you have solved this, attempted this and solved this on your own, and you got the same result as what I am getting. Okay. Now let's go to the third problem. Now this is the third problem. So here the question is, find the Thevenin's equivalent circuit across terminals AB. As always, the same question. So let's start with the step 1. Again, you can pause the video now. You can try it yourself, this particular answer. And if you get the correct answer, good, congratulations. And otherwise also fine, you have attempted. Okay, so many people don't even attempt it. So don't be in that group. Attempt it and then see what answer you get. Okay, so step 1. What is step 1? Finding RTH, Thevenin's resistance. So how to find Thevenin's resistance? Short the voltage sources and open the current sources. Okay, so all the current sources open circuit, all the voltage sources short circuit, and find the equivalent resistance between A. So here let us open circuit this. Okay, so this is open circuit. Then this is 10. Then this is 2. Here it is short circuit, so I get point B. I'm sorry. So this is 2. Then here I go up. So there is an open circuit here, and then there is a short circuit here. Okay, so this is short circuit. Then I have 8 here, 8 ohms, and then I have this point A. Okay, so A, B is here, and this is it. So this branch is completely open because there is open circuit here. Current will be 0 in this, so nothing is there. Here also current will be 0. So effectively 8, 10 and 2. Okay, so the resistance between A and B is nothing but 8 series with 10 in series with 2. Okay, so RTH is 8 plus 10 plus 2, which is 20 ohms. Okay, so I am getting the Thevenin's RTH equal to 20 ohms. Next, I need to find the VTH, Thevenin's voltage. Okay, so how do I find? Now introduce all the sources. Okay, so and then you see. So anyway, so this AB is still open. So let me redraw the circuit here once again for easy reference. So here it is 2 amperes of current. This is 10 ohms, this is 4 ohms, and then I have 2 branches. This is 3 amperes, and I'll just draw like a simple 10 volt symbol, and then 8 ohms here, and then this point is A. Okay. And down we have 2 and 20. So let us start by marking the polarity of voltages. Okay, so here it is plus and minus. Here it is minus and plus. Okay, so at least this one we know. So now you see A and B are open, so therefore here the current will be 0. So therefore here also current will be 0, because if any current comes from here, it cannot simply circulate here. It has to go somewhere out, but nothing is going out, so nothing current also will come in. So this is 0 amperes. Okay, so that's the first interesting thing. Now here also the current will be 0 amperes. Okay, and here anyway it is open circuited. Therefore this 3 amps is actually circulating within. Okay, so the 3 amps will be going into 8 amps, 8 ohms resistance, and circulating like this. So what is the voltage drop across this one? So here the current is 3 amperes. Therefore the voltage drop 8 3s are 24, and this side will be plus, this side will be minus, because current goes from higher potential to lower potential because current is going this way. So it's coming this way and then going this way. So this is plus minus 24 volts. Similarly here there is no voltage. Okay, 0 into 2 is 0, but there is a 20 volts here. Now we need to find this one. So this 2 amperes current, here it is anyway 2 amperes we know, and here since it is 0, so the 2 ampere current will be going downwards, and 2 amperes in 10 ohms will be 20 volts. Okay, so here the voltage will be 20 volts, but this voltage will have higher potential up and lower potential down because current goes from higher potential to lower potential. So plus minus will be like this. Now what is Thevenin's voltage? VTH, nothing but VAB. What is VAB? VAB nothing but KVL from B to A. So now you start at B. What is happening? From positive terminal I am jumping towards negative terminal, so I am losing the voltage. So minus 20. So this is minus 20, and here there is no voltage because current is 0. Then this 10 ohms has a 20 volts because 2 amperes current is there, and from negative side I am going towards positive. I am going against the current, so I am gaining 20 volts. Okay, so plus 20. So 20 is getting cancelled instantly. Now here anyway 0, and now come here, it is minus towards plus side I am going, so plus 24. Okay, so these 20s will cancel. Therefore finally what we remain is 24 volts. Okay, so the answer here, the Thevenin's voltage is 24 volts. Okay, so again, if you had solved this problem yourself and you got these answers, very good, congratulations. If not, also very good, at least you have tried and you identify where you got the mistake. And by the way, I myself might have made a mistake, so if I had made a mistake, let me know. Okay, so this is third question. Okay, so let's go to the fourth question. Okay, so now this is fourth question. Again the question is same. Find the Thevenin's equivalent circuit across the terminals A and B. Okay, so let's look at this now. Step 1 again. So finding RTH. Okay, the Thevenin's equivalent resistance. So what we are looking for is this Thevenin's equivalent source. So VTH and RTH. This is A and B. So now what we have here, finding RTH. So what you have to do, current sources open circuit, voltage sources short circuit. So the equivalent circuit becomes 3 parallel 6, right, these two branches, then here 4 and 2. This is A and B. Okay, so simple circuit. This 4 remains as it is, 2 remains as it is, 3 and 6 are in parallel. So 3 and 6 parallel means it will be 2. Okay, so why 3 into 6 divided by 3 plus 6. Okay, so we have 2 ohms. Okay, so 2 and 4 and 2. So 4 plus 2 plus 2. So 8 ohms. Okay, so RTH is equal to 6 parallel 3 plus 4 plus 2. So that is nothing but 8 ohms. Okay, so we have solved this. In fact, you can just you don't have to put pen on paper. You just look at the circuit and you can solve it. Okay. Next, finding, step 2 is finding the find VTH, Thevenin's voltage. So let's read out the circuit. See, A is anyway, I'll just draw the circuit here. Reintroduce the sources. So 6 amperes is here and going towards left side. Then we have a 4 ohm resistance here. Then we have 3 here, 18 here, and 6 here. So you see this again with simple observation, 6 amperes will go down and go this way because here the current is 0. So no current will enter from this part of the circuit to this part of the circuit. So only 6 will keep on circulating here. So 6 amperes. So 6 amperes into 4 ohms will be 24 volts. but this side will be positive side, so plus 24 volts and minus here. Okay, so that is how you give the polarity. Meanwhile here it will be 0 volts because the current is 0 amperes here going towards B, and 18 volts divided by 9, so this 3 and 6 will become series connected, so 9 ohms, so V by R, so 18 by 9, that will be 2 amperes here. Now the 2 amperes going in 6 ohms will be 12 volts. Okay, so now upside will be plus and downside will be minus because the current is going from here to down. Now simply finding VTH is nothing but VAB, and VAB is nothing but KVL from B to A, Kirchhoff's voltage law applied from B to A to find the VAB. So from B you start going towards left, so current is 0, so no voltage drop here. Here minus side to plus side 12 volts, so gain 12 volts, so plus 12 volts, and from here plus side going towards minus side, so minus 24 volts, so this is nothing but minus 12 volts. So Thevenin's voltage is minus 12 volts. So in other words, you need to actually reverse the terminals here, and then you will get the actual this thing. But anyway, this is the solution for the fourth question. So again, it's not very difficult. You can just mentally, calculate it, but you can also do it like this. Okay, let's go to the fifth problem and the last one in this particular video. Mind you, I have some more problems that I want to show you, but anyway, let's come to the last one in this particular video. So here we need to apply some concept actually. So first let's get rid of this load resistance 3 ohms. Okay, in this case RL equal to 3 ohms. Okay, so now you can pause the video, remove the 3 ohms resistance and find out the Thevenin's equivalent, and then introduce the 3 ohms resistance and find the potential difference across the terminals A and B. In other words, if you find the current here, you can find the potential difference here. Anyway, so first let us find the Thevenin's impedance, so or Thevenin's resistance. So step 1, RTH is what? Okay. So remove the 3 and then short circuit all 3 voltage sources. So I'll get 6 parallel 6 parallel 3. So this is my simple circuit. Now 6 parallel 6 is half, that means 3. Again 3 parallel 3 is 1.5 because it will divide by 2. So RTH becomes 1.5 ohms. Okay, so let me mark that here, 1.5 ohms RTH. Then there will be a voltage, and then there will be terminals A and B, and again we will be reintroducing the 3 ohms resistance here. And then our objective is to find the voltage drop across AB. Now question is, what is VTH? Okay, so in order to determine VTH, again you have to reintroduce back all these sources, right? So let's try to do that. Okay, I'll draw the circuit here. 6 ohms, 6 volts, 6 ohms. Here the battery is exactly same, but the polarity is different, 6 volts, and I have 3 ohms and 4.5 volts, and then I have these terminals A and B. Okay, so now the objective now is to find out the voltage between A and B without the 3 ohm resistance, or in other words voltage across these 2 points, okay, because A and B, or these 2 points or these 2 points. So how do you find? So for this, without knowing the currents in this, you cannot find the voltages. But what happens, how do you find the current in this? Okay, so there are again 2 ways. You can apply what you call Thevenin's theorem once again, or you can apply superposition, because 3 different voltage sources are there and a circuit is there. You can apply superposition theorem. Now let's assume that we apply superposition theorem. So in superposition theorem, what we do is that we short circuit these 2 branches and find the currents. Then that is currents due to the first source. Then the second source will come into picture. Then we'll short circuit the other 2 branches and find the current in the second source. Now look at the symmetry of the circuit. Okay, 6 and 6 and 6 and 6, just only the polarity is reversed. So let's say I take the first battery, and if I short circuit these two and then find the current due to the first voltage source 6 volts in this 3 ohms resistance, it will be downwards, right? Next, I short circuit this and then find the current through this 3 ohms resistance. Even this is short circuit. Why do all this? Let me take the first this one, then 6 ohms, then I get 6 volts, then this is 6 and this is 3. This is one circuit considering only the first source. So let's say here the current going downward is IA. Okay. Meanwhile, if I consider the second source, then what happens in the superposition theorem? So this will be 6 and this will be 6. Here the polarity is different, and then here it is 3. In this case, the current IB will be equal and opposite to IA, right? Because both circuits are same, symmetrical, but just the opposite. So in the superposition theorem, these two will cancel out each other. Whatever currents in, not only in this branch but all branches. So these two will simply cancel out each other, and only effect will be of that of 4.5 volt. Okay. So now consider the third voltage. Okay. So in the third voltage, you circuit the other two. Okay. So let us do that. So here we have 6, here we have 6, then here we have 3, and here we have 4.5. Okay. So this is our simple circuit. Now 6 parallel 6 is 3. 3 series 3 is again 6. So the current here will be 4.5 divided by 6. Okay. So that will be the current. 4.5 divided by 6. 0.75 amperes. Okay. So this current will be going upwards. Okay. Now this, what will be the voltage drop in this now? So the voltage drop in that, so basically now we have A here and B here, right? So we need to find the potential difference between AB. So VTH, and the other two currents anyway cancelled. So VTH equal to VAB is equal to Kirchhoff's voltage law from B to A. So that is nothing but you start from B, you go up, it will increase by 4.5. So plus 4.5, increase your voltage. Then you are going in the same direction of current, so your voltage drops. So minus 3 into 0.75. Okay, so this is your voltage. So now let's do this. So 3 into 0.75 is 2.25. So 4.5 minus 2.25. So 4.5 minus 2.25. So that is 2.25 volt. So this is our Thevenin's voltage. Okay, so here if I say 2.25 volts. So this completes the Thevenin's equivalent. But then again, be careful in electrical engineering. Look at the question what is asked, and finally don't stop until you get that. Using Thevenin's theorem, calculate the PD across the terminals A and B. What is the potential difference across terminals A and B? Now look at this one. So simple potential divider rule I can apply. So 2.25. After introducing the load resistance, PD across A and B will be, so 2.25 multiplied by 3 by 3 plus 1.5, okay, or 2.25 multiplied by 3 by 4.5. Okay, so what is that? 2.25 into 3 divided by 4.5. Okay, so it is 1.5 volts. Okay, so this is the actual final answer for this circuit. Okay. So I hope again your answer matches with my answer. Okay, so if not, just check whether where I have made the mistake. But then the conceptual point here is to understand the symmetry of the circuit, and thereby you can avoid a lot of calculations. And this kind of thing in future you should gain so much experience of solving these problems that you don't have to put pen on paper. Just look at the, concentrate on the circuit, and mentally you can solve it, and then finally get the answer. So anyway, I think we started off this video by showing the 5 problems, and we solved all these problems. So let's end this video here. This is a series of this is the fifth video in a series of playlist on Thevenin's theorem. In fact, earlier we have I have another series of videos on superposition theorem. So those who are seeing this Thevenin's theorem also refer to a separate playlist on superposition theorem in my next video. Now I will just add one more video in this particular playlist where I am going to show some practice problems, and then they are actually not practice problems, but without touching pen on paper you can actually just by observation and mental calculation you can solve them. So let's look at that in the next video. So see you in the next video. If you like this video, please press the like button, and please subscribe to my channel and refer this channel to your friends. And also let me know your thoughts, how you feel, what is, if there is any place where you are finding difficulty, let me know. Thank you so much.